So what is the bubble sort algorithm? Well, it's in the name, right? It's just a sorting algorithm. How does it work, though? That's the thing. And so, as usual, if you don't find this explanation intuitive, there's a ton of resources online you can use. And this one's a relatively simple algorithm, I think. So the way bubble sort is going to work is, it's depending on how you configure it, but most typically you'll find that the largest element is going to be sorted here on the rightmost side, and the smallest element will be here, and that would be for ascending order. And the way it does that is, we can use a loop, right? So we could say for I equals 0, or we can use j. Let's use j because this is actually going to be an inner loop, and I'll explain why in a second. But the way in which this algorithm is functioning essentially is, we start off here, right? And we can say this is j equals 0, and we compare it, right? Compare the jth element, which is 0 in this case, to j plus 1, right? And we say, okay, is the jth element greater than, so in this instance, let's say the jth element was 5, and let's say this was 4 here. It would say, yeah, actually, the jth element is greater than the j plus 1 element, or the element directly in front of it, in which case you swap them. You perform a swapping operation on the two, and you keep doing that all the way to the end here. And so what happens is that at the end of the bubble sort pass, right, as you're going across, and then, so this is at j equals 0, this would be j equal 1, 2, 3, and 4. When you finally get here, the largest element after each pass is going to be sorted, okay? And let's assume that 5 was the largest element. So let's say we had 3 here, and then we had 2 here. So this would become 5, right? And then the algorithm would come over here, and it would swap it with the 3. Alright, so 3 would be here, 5 would be here, and then it would come here, and it would swap it with the 2. So 5 and 2 would now swap places, and then whatever element was here, let's say 1 was here, and 5 was now here, then we'd swap the 2, right? And so at the end, we ended up with 5. After the first pass, the largest element is always going to be sorted. Hopefully that's clear. If not, just feel free to YouTube this one. It's a very simple algorithm. What I do find a lot of students misunderstanding, though, is the optimizations, right? How long do you have to run this loop? So we see that there are n items, right? 1, 2, 3, 4, 5. You actually have to run this loop n minus 1 times. Why? Because, let me get my highlighter. So we had 5 elements like so, right? 2, 3, 4, 5. And then on the first pass, right? Let me use this one. On the first pass, this element here is sorted, right? Fair enough. On the next pass, this one's sorted. On the next pass, this one's sorted. And then on the next pass, this one is sorted. Do you really have to go and sort this element again? No, it's already sorted, right? This would be the smallest element. The smallest element, after n minus 1 passes, right? If we had 5 elements, the smallest element is already sorted. You don't have to go ahead and call this, do all these swaps again. It's just a waste of resources. And so that's a small little, well, not small, it's quite a difference, but that's the optimization, n minus 1, right? And so it's nothing to do with range, right? It's to do with the optimization in this case. Now, there's another thing that you do have to consider. Where is it? Okay, so we know, let me get to that first. So we know, right, that this entire expression here, we know it has to run n minus 1 times, right? Now, what about this, the actual nitty-gritty here of this j equals 0? So we know this is some for loop here, right? This is an outer loop. We can call this an outer loop. So if we were to define this, let me define this. Everything inside of these red braces as some function, right? Think of, abstract it in your mind as some function. We're running this function n minus 1 times, okay? So this is an inner loop, and this is an outer loop. How many times do we have to run the inner loop? Because we've already determined how much time, it's n minus 1 for the outer loop, right? Because the least element here is going to be sorted. But what about the inner loop? What are we doing here? And so if you look very carefully, let's go 1, 2, 3, 4, and 5 elements again, just for consistency. And so we're going to start here, right? And we compare with the next element, and then we move all the way down. What happens if we get to the last element and we try to compare jth element with j plus 1? we'd go out of bounds, right? Let's suppose this was our 5. And typically what happens, right, is that there's a 0 here, right? And it's going to say, oh yeah, well 5 is actually greater than 0, and it's going to swap this 0 in here. And so a lot of times, if you don't carefully account for this situation, you end up with a 0 here. So what you want, right, is your loop to stop at this condition here. Okay, so you want it to also stop at n-1. And that's to prevent it from overflowing outside of your array. So for the inner loop, n-1 means, right, that you're preventing it from overflowing. Okay, so it'll always stop here, and it'll compare to the last element, so you're not comparing with something out of bounds of the array. Hopefully that's clear to you. Now there's another small optimization that you'll see. It's n minus I, right, minus 1. Let me get the green highlighter. So the n and the minus 1 we see here as absolutely important, right, so that we don't go out of bounds. The minus I now is the optimization, like previously with our outer loop, where n-1 is an optimization for the outer loop. It's not entirely necessary, but it's an optimization. The minus I is an optimization here. And I'll show you in the code, because after you've sorted here, right, say we made the first pass, right, we ran this program once, right, we ran our function once, and now we know that the largest element is already sorted, right? Do we really have to go now and sort through again? No, we don't have to for the inner loop. You can subtract off that I that we've already sorted. So that's how that works. And then this one would be sorted on the next pass, and then this one would be sorted on the next pass, and then this one would be sorted on the next pass. See, do you see how that's functioning? So the I, as I grows, right, you're subtracting it away from the number of passes that you have to make inside of here. Okay, let's just see that in practice, and then hopefully it'll make some sense to you. Whoopsie daisy, not that. Let's just get straight into coding. Don't think we need much here. This one. Okay. Sorry, I was just getting a couple of messages there. Alright, so let's just start off by saying integer array, size of the array. I hope you know, you don't have to do this, but define size, we'll just say 5. And let's just say 3, 2, 1, like this. Yeah, I think so. It should be fine. And you can actually just get the size of the array as well by finding the size of the actual array and then dividing it by the size of an integer, and you'll be able to get the size that way if you wanted to, but I'm just going to stick to this one. Okay, no issues there, and we'll need a bubble sort function, so we'll pass in the array, we'll pass in the size, and this is going to be our bubble sort implementation. Size. Okay, a lot of times I see people putting in as the parameter integer array, like so. Oh my god, that's so ugly. That's so unintuitive as well. It kind of shows me that you don't really understand what's actually going on. So you should know when you pass in an array, it's perfectly fine, you can do it, right? But man, to me, right, it just doesn't make any sense. Not good. Anyways, you're passing in an array, and whenever you're passing in an array to a function, it's going to decay to a pointer, right, to the start of your array. And that's why we can use integer start array, because we're expecting a pointer, right? We know beforehand that it's going to return a pointer to this element 5 here, the first element, the 0th element. Okay, so we're expecting an integer pointer. That's what we're expecting. I hope that's clear. If not, don't know what to tell you. Alright, so okay, as I was saying, we're going to need 2 loops, right? The first outer loop, integer I equals 0, and this will be I is less than size minus 1, right? This was the n-1 case optimization I was telling you about. And then the inner loop is just the function, quote unquote function, that I was trying to explain to you, or the actual execution of the algorithm. We'll say int j equals 0, j is less than size minus 1. This is not an optimization, it's just to ensure you don't go out of bounds, okay? Up here is an optimization, this not an optimization. Hopefully that distinction is already clear to you. And as I was saying, integer x is equal to, and then you can use this notation here, right? Well, we just grab the jth element, like so as I was explaining earlier, and then we say grab the j plus 1, as well j plus 1. Space it out like so, it just looks better. Alright, and I hope you know as well that I personally prefer to do this, but I'm not going to, I don't want to confuse you guys. But if you were to just dereference this pointer, it's going to give you the jth element. And if you dereference the pointer plus 1, it would give you the j plus 1, okay? So you can do that as well if you'd like, but I'll just do this for simplicity's sake. It's easier to work with as well, actually, in this context. Okay, and then you need to check the two, right? So you just say if x is greater than y, as I was explaining. And if it is, then you swap, essentially. Then you can say array, right? Array j, the jth element, is equal to x, right? Is equal to y, rather, right? And then we say array j plus 1, you can set that equal to x. Okay, so you've essentially swapped the two elements around. You can take your time and go it over if that was a bit too fast. But I think they should do the swap. Oops. And that's quite literally it. That's your bubble sort algorithm implemented. Yeah, the most complicated algorithm in history. And let's just do a print array. We'll take an integer array pointer and the size. And we'll need a for loop. So we can just iterate over the array. There we go. And then we'll just say printf %d, print out array index I, and yeah, and we can probably just put a new line here as well. It'll look better. Great, let's ensure we don't get any compilation errors. We didn't, surprisingly. And so let's go ahead, and the first thing we can do is, I'll come here, right? I'll put a printf here. Oops, can't type today. So we'll say pass, right? We'll put the pass number here. This will be I, so we know the pass number, and then after every single pass, so that would be, is it here? No, it's here. After every single pass, then we're just going to print out what the new array looks like. Alright, so we just call the function here. Print array, like so. Pass in array, pass in size. Let's see if that works. There we go. You can see after 3 passes, right, that it's 1, 2, 3, 4, 5, right? And let me go ahead and remove this -1 from up here, and I'll show you that it's completely fine. It's just an optimization. So you see here on pass 3 that it's already sorted, and then on pass 4 we sorted it again, right? That's because the smallest element is already sorted. So as I was explaining, so that's where this -1 comes in. Now there's another, this is not a perfect implementation as yet. We can do another optimization in here, and you'll see it as size -I -1. Right, so let's just go ahead and print out what's actually going on inside of here. Let's go printf. Hopefully I can get the point across, yeah? So we'll ask, right, is x greater than y, right? And it's just going to grab the values here. So we're checking, is x greater than y? And if it is, then we'll say, we'll printf, yes, new line, swap. And we'll put this on new line so it's easier to read. Hopefully that that's going to give our point. So here on pass 0, right, it's going to say is 5 greater than 4. I think it's going to be helpful at the very start here for me to also just print array, so I can just very easily go it over with you guys. Great. So we have the original array here that we put in to the function. And so on path 0, right, j is going to be this element 5, right? And this j plus 1 would be 4. Is 5 greater than 4? Yes, swap, right? And then, so now 5 is here, right? Is 5 greater than 3? Right? Yeah, swap. 5 greater than 2? Yeah, swap. 5 greater than 1? Yes, swap again. Okay, and so after all of that now, we see that we have 5 all the way at the end here, sorted, right? Great. And then it's going to do the same thing again here. 4 greater than 3, 4 greater than 2, 4 greater than 1, right? But do you see here that it's checking if 4 is greater than 5? Do we really need to check that? We don't, right? Because we already know that this element, the last element, is sorted, okay? And you'll see as you get further and further into the program, it becomes more wasteful, right? So here, look, if you look on the third pass, right? The third pass is just going to be, okay, it's 2 greater than 1. Yeah, it is, right? So you just swap. Then it's checking is 2 greater than 3, right? It doesn't have to check that. Is 3 greater than 4? It doesn't have to check that. Is 4 greater than 5? It doesn't have to check that either, right? So that's 1, 2, 3 total checks that we're wasting here, right? Essentially, on the third pass. And that number is not random as well. If you can see, it's I. It's literally I, right? The number I. That's the number of checks that we're wasting. So that's why you're subtracting away off I. Right, so you don't have to check against the already sorted elements then, if that makes it a bit more clear. I don't think I can explain it any better than that. Why you're subtracting off I? Because I just represents the number of sorted elements or the number of passes that you've already made. And so if you come down here now and you put it in, right, size minus I minus 1. You'll see that it's no longer doing that, right? If you can see here, all the way down to pass 3, it's just going to check is 2 greater than 1, and then it's going to swap. It's not going to check, you know, is 2 greater than 3, and all the way like that. It's not going to do that. So, alright, that should conclude our little video on bubble sort, and hopefully you found it helpful. It's an otherwise very simple algorithm that you can already tell, but alright, just wanted to do that one for you guys. Peace.